Hello everyone, welcome back to my channel Geography with Joy. This is Subhalakshmi back again with another interesting video. Friends, we are discussing about rocks and today we are going to discuss about metamorphic rocks. This is again a very interesting topic and I am sure you are going to enjoy my video thoroughly. In my previous videos, we had discussed about igneous rocks and sedimentary rocks in detail, and I hope you have gone through those videos and understood the concept thoroughly. Today, we will exclusively emphasize on metamorphic rocks. Then, without much delay, let's start the topic. Topic to be discussed today is the metamorphic rocks, and the outline of the topic is meaning of metamorphism, causes and factors responsible for metamorphism, characteristics of metamorphic rocks, classification, and at the end, uses and economic importance of metamorphic rocks in our day-to-day life. Let's discuss the topic in detail now. Metamorphic rocks. The word metamorphic means change of form. It is derived from two Greek words. Meta means change and morph means form. Metamorphic rocks are those which are formed by the process of metamorphism or alteration of pre-existing rocks. These rocks are formed under the action of heat, pressure, and the weight of the overlying rocks. Igneous, sedimentary, or other previously metamorphosed rocks may be subjected to changes under the effect of heat, pressure, and the weight of the overlying rocks. They completely change their character and appearance when earth movements, volcanoes, or mountain building forces subject the existing rocks to intense heat and pressure. If in the process rock melts, they are no more metamorphic but become igneous rocks again. During the process of metamorphism, the original minerals get altered and new minerals are formed. Thus, they are also called as changed rocks or altered rocks. They combine together to form rocks which are harder and more resistant than the original rocks. Metamorphic rocks have their minerals arranged in a series of bands. This is called foliation. Have a look at these pictures. These are few metamorphic rocks which are formed by the process of metamorphism. This is marble. Limestone gets altered to form a rock called marble. Limestone exposed to heat and pressure results in larger and more uniform crystals. Marble is used for making statues and for the construction of buildings. This is slate. Slate is a metamorphosed form of shale. Shale exposed to heat and pressure that splits into hard, flat plates. Slate has a tendency to break into thin sheets. Slate is also used for roofing of buildings. This is gneiss. Granite gets converted into gneiss. Gneiss is a rock which is resulting from the exposure of clastic sedimentary or intrusive igneous rocks due to heat and pressure. And this is quartzite. Sandstone gets metamorphosed to form a rock called quartzite. Quartzite is one of the most resistant type of rocks. Causes of metamorphism. Metamorphism occurs because of certain regions. What are those? Let's have a look. Metamorphism occurs because some minerals are stable only under certain conditions of pressure and temperature. When pressure and temperature change, chemical reactions occur. The most important agents of metamorphism include temperature, pressure, and fluids. Out of that, the most important agent is heat because it provides the energy to drive the chemical changes that result in the recrystallization of minerals. The main factors that control metamorphic processes are the mineral and chemical composition of the parent rocks, the temperature at which metamorphism takes place. Heat sources include magma, geothermal heat, and from friction along the faults. The amount and type of pressure during metamorphism. And the pressure sources include the weight of overlying rocks deep in the earth. The type of fluids, it is mostly water that are present during metamorphism. The amount of time available for metamorphism and endogenic forces. The origin of endogenic force is caused by the contraction and expansion of rocks due to variation in thermal conditions and temperature inside the earth. These forces are responsible for creation of many landforms. For example, mountain building forces, earthquakes, volcanism, etc. Can you identify this picture? This is the world famous marble caves of Lake General Carrara in Chile. This is completely made up of marble. Marble is a metamorphic rock. The marble caves is a geological formation of unusual beauty. These caves have formed in pure marble and are bathed in the deep blue water of General Carrara Lake. These calcium carbonate formations were declared as the sanctuary of the nature. Now, let's talk about the characteristics of metamorphic rocks. Metamorphic rocks are formed due to change in texture and mineral composition of the pre-existing rocks. The pre-existing rocks may be igneous, sedimentary, or even metamorphic rocks. New minerals are formed during the process of metamorphism. Some rocks after metamorphism become harder than their original form. For example, marble from limestone, quartzite from sandstone, and diamond from carbon. The fossils of the original sedimentary rocks are destroyed and therefore they do not contain fossils. Extreme pressure may lead to foliation, the flat layers that form in the rocks due to heavy pressure. Metamorphic rocks may also be non-foliated. For example, quartzite, limestone, etc. Many of the metamorphic rocks may split along the bedding planes. For example, mica schist. Most of the metamorphic rocks are impermeable, but some of them are permeable. For example, gneiss. They may react with acid. They have closely banded structure with the interlocking of crystals. Precious minerals like rubies and sapphires are born out of this process of rock formation. Metamorphic rocks provide a record of the processes that occurred inside the earth as the rock was subjected to changing physical and chemical conditions. This gives the geologist the inside information of the earth. The next important part of the topic is the classification of metamorphic rocks. Metamorphic rocks can be classified based on the agency involved and the extent of the area. On the basis of agency involved in transformation, two types of metamorphism have been observed. They are thermal metamorphism and dynamic metamorphism. And on the basis of the extent of the area, metamorphism are of two types. They are contact metamorphism and regional metamorphism. Let's discuss each one of them now in detail. Thermal metamorphism. This type of change takes place under the influence of very high temperature and is called thermal metamorphism. Heat sources include magma, geothermal heat, and friction along faults. Under such conditions, some rocks undergo certain changes to form a new type of rock. For example, sandstone changes into quartzite, shale changes into slate, coal changes into graphite, and limestone changes into marble. This is the Taj Mahal, the one of the wonders of the world. This is entirely made up of Makrana marble. Makrana marble is a type of white marble popular for use in sculpture and building decor. It is mined in the town of Makrana in Rajasthan, India, and was used in the construction of several iconic monuments such as the Taj Mahal in Agra and the Victoria Memorial in Kolkata. Dynamic metamorphism. Dynamic metamorphism occurs when the transformation takes place mainly because of pressure at a great depth within the Earth's crust. Pressure sources include the weight of the overlying rocks deep inside the Earth. Under such conditions, some rocks undergo certain changes to form a new type of rock. For example, granite changes into gneiss, clay changes into schist. Chemically active hot gases, while passing through the rocks, change their chemical composition. Under conditions of this change, minerals get arranged in a series of bands known as foliation. Look at these pictures. This is gneiss, which is getting converted from granite due to heavy pressure. And this is schist, which is metamorphosed from shale or mudstone because of heavy pressure and heat. These are metamorphic rocks. Coming to the contact metamorphism. It is on the basis of location. This takes place in the regions of volcanic activity or mountain building. Molten materials come in contact with the existing rocks under tremendous heat over a small area. This is known as contact or local thermal metamorphism. This type of metamorphism alters the materials and the texture of the rocks chemically and crystallizes them due to the great heat from an adjoining body of intruding magma. Chemical changes may form valuable minerals such as garnet due to contact with hot magma and adjacent thermal rocks inside the earth, causing crystal growth so that the original parent rock is metamorphosed. The magma hardens over time. The zone of metamorphic rock around the hardened magma is called an aureole, meaning radiant light. Contact metamorphism produces non-foliated rocks such as marble, quartzite, and hornfels. This is a huge piece of hornfels rock. Hornfels is a fine-grained metamorphic rock and it is the group for a series of contact metamorphic rocks that have been baked under high temperatures by the heat of igneous intrusions and as a result have become massive, splintery, extremely hard and in some cases exceedingly tough and durable. In general, hornfels are fine-grained and dark in color. The next is regional metamorphism. When metamorphism takes place over a large area due to Earth's movement, it is called regional metamorphism. Due to mountain building process, igneous and sedimentary rocks are buried deep inside the Earth's crust. The pressure of overlying rocks and the intense heat caused by large-scale earth movements change such rocks. Regional metamorphism usually results in forming metamorphic rocks that are strongly foliated, such as slates, schist, and gneisses. And this is a slate rock. Slate is a low-grade metamorphic rock generally formed by the metamorphosis of mudstone or shale or sometimes basalt under relatively low pressure and temperature conditions. So far, you have learned about the classification of metamorphic rocks in detail. Let's summarize it with the help of this mind map. Under heat and pressure, both igneous and sedimentary rocks transform into metamorphic rocks. Two types of metamorphism have been observed based on the agency of transformation. They are thermal metamorphism. This type of change takes place under the influence of very high temperature and the agent is heat. And the dynamic metamorphism. This type of change takes place under immense pressure. Based on the extent of area, metamorphism again can be of two types. They are contact metamorphism. This takes place in the regions of volcanic activity or mountain building. Molten matter comes in contact with the existing rocks under tremendous heat over a small area. And regional metamorphism. When metamorphism takes place over a large area, regional metamorphism occurs. At the end, let's talk about the economic importance of metamorphic rocks. They contain useful materials like gneiss, quartzite, graphite, and marble. Gneiss is used as a raw material in the construction of buildings. Quartzite is very hard and is often crushed and used in building railroad tracks. Quartzite is also used in glassmaking. Graphite is used for making pencils and batteries. Marble is used in making statues and decorative items like vases and also building materials. One of the world's wonders, the Taj Mahal, was built entirely with marbles. Metamorphic rocks are associated with a number of valuable minerals. Metallic minerals like gold and silver and many precious stones like diamond, ruby and sapphire are found in these rocks. The study of metamorphic rocks play a significant role in the reconstruction of our Earth's history. Metamorphic rocks are hard, which make them durable. Garnets are used as gemstones and abrasive. Talc is used in cosmetics, paints, and lubricants. Asbestos is used for insulation and fireproofings. Slate is a good roofing material, but people also use it as decorative gardening stones, as a base for snooker tables, and also as a writing board in the classrooms. And that's all for today. I hope you have understood the topic and enjoyed my video too. We will continue our journey with rocks with another interesting video. In my next video, we will discuss about rock cycle and the importance of rocks. Stay connected. Don't forget to like and share my video and of course to subscribe. Thanks for watching. See you again. Till then, take care and have a nice day.